Okay, so let us try to solve this indeterminate beam ABC, no, with a load of 3 kilonewton concentrated load and a 4 kilonewton per meter uniformly distributed load. Okay, so this is seaboard November 1998. So ladtugay na gid kay siya. So wala man gi-state diri nga gamit ta og modified stiffness. Okay, so first ato na siya sang consider as a relative stiffness. So despite nga hinge support katong step 1 na to. Okay, so let's proceed. So ang pag-compute sa moment at A, moment at B, moment at C. But kung imong analyze on, imong tanawon kung simply supported sa pinaka-ends niya A and C, so automatically moments are 0. Isagun sa pang method imong gamiton 3 moment, area moment, or sa paman fixed end moment, moment distribution. So 0 gyapon na ang sa simple support. So imong aim is to compute the internal moment B. Okay, so let's proceed with step 1. So step 1, compute the relative stiffness. So K, sorry. So K first is unsa matong unang nakuhaon. You have to compute for KAB. So KAB is I over L. So wala man ningon nga nidako ang pikas, no? Or wala ningon nga ang dimension sa BC is twice sa AB. So it is assumed that the moment of inertia all throughout ABC is equal to 1. I over L. So ang L for AB is 5 plus 3, 8. The next is to compute KBC, the relative stiffness of span BC. So that is I over 5. Okay. Next is the distribution factor. So again, distribution factor for pin or ruler is equal to 1. So therefore, distribution factor at A is equal to 1.0. Distribution factor for end C is equal to 1.0. And then distribution factor B to A, so B to A na ta sa center, duha yung sa internal moment, internal supports, duha yung distribution factors towards the left and towards the right. So towards the left, that is BA. Okay, so formula is K over summation of K. So K for BA or AB is I over 8 divided by summation of relative stiffness. So that is I over 8 plus I over 5. So pila na siya? That is 0.38. Distribution factor still at the internal support pero towards the right. So instead of BA, padung ta BC na siya. So what is K sa BC? That is I over 5 divided by I over 8 plus I over 5. So pila pud ni? It is, using your calculators, that is 0.62. So distribution factor at each support is equal to 1. Okay, so unsa may sunod na tong buhaton? Umana ta sa step 1 and step 2. The next is fixed end moment, step 3. So again, nakita na to gain na the fixed end moment for simply supported is PAB squared over L squared. So pilay P, that is fixed end moment sa kwan ha, sa kanina ay simple support nga 3 kilonewton. So that is 3 times 5 times 3 squared over 8 squared. Pilay value 2.11 kilonewton meter. And for fixed end moment nga isa, it is PA squared B per L squared. So 3 times 5 squared times 3, pilay value 3.52 kilonewton meter. Then FEM for uniformly distributed load is WL squared over 12. So 4 times 5 squared over 12, we have 8.33. Okay. Okay na. So nakuha na nato ang step 1 to step 3. So step 4, let's balance the joints. Okay? Okay, so how will we balance the joint? So i-draw na to siya, no? Para makita na to. Okay, so kay A, B, and C. Okay. So ngayon ang buhaton, mag-put count boxes for each. So ato siya pangalan og A, B, and C. Si A, si B, o si C. Okay, so we have distribution factors. DF for A is 1.0. For BA, that is distribution factor 0.38. Mo na itong ipang solve gay na. Then for BC is 0.62. And for C simple support 1.0. Okay, so next is to compute to put the fixed end moment para mabalance na to. Gani siya ang atong ipang balance. Kaya wala unbalanced moment man eh. Ibali wala pa nimo na distribute. So you have a negative 2.11. So again, pag mag FEM ka, negative ang left, positive ang right. Negative ang left, positive ang right. Para sa PCAS. So that is positive 3.52 for the right. Then sa left for BC, we have negative 8.33. Negative WL squared over 12 and positive WL squared over 12. Okay, so unbalanced pa siya. Pasabot na kay negative 2.11 at A nga wala pa siya naka-affect ng B. So dapat maapektuhan man gina niya si B, no? Si 3 kN nga load maka-cause og rotation kang B. Di ba? Murag ma-transfer siya dapat. So ang next step is to balance the joints after writing the fixed end moment. So negative, positive din eh. And negative, positive sa right. Okay. So muna akong pasabot kayo na sa left is clockwise. So that is clockwise, negative, counterclockwise, positive, clockwise, negative, counterclockwise, negative moment, positive moment, negative moment, and positive moment. Okay, so next is balancing the joints. So by balancing the joints, you multiply the FEM by the distribution factor, then change the sign. Again, take note, to balance the joints, you multiply the sum of the moments, I mean the fixed end moments sa kanang point, say point A or point B or point C, sum up the moment multiplied by the distribution factor, then change the sign. Okay, so for A, we have negative 2.11, wala kay laing maad, kay isa ra magida moment niya, multiplied by distribution factor 1.0, you have a positive, no? Change the sign negative, so you have 2.11 positive. The next is 3.52. Ito, 3.52. 3.52 plus negative 8.33 multiplied by 0.38. Pila? 3.52 minus 8.33 times 0.38, no? Multiplied by distribution factor. We have, so kanin negative na nidaan kay mas dako man ang value sa 8.33. So negative 1.83. But you have to change the sign. So it would be positive. Sa PCAS na pod, wala na to negative. So negative summation of FEM. Still negative 3. Quantity of 3.52 plus negative 8.33 multiplied by 0.62. So you have a positive 2.98. Then fixed end moment 8.33 times 1, that is still 8.33. Then change the sign, we have negative 8.33. Okay, so we're done with the balancing the joints. So next is for us to have the carryover moment. So i-carry nimo siya from left to right. So that is 1/2 of your moment. 1/2 of 2.11, we have positive 1.06. So atong mga nasa sides, carry niyo pa lang diri. So carry 8.33 divided by 2, we have negative 4.17. Okay na. So kani siya isa ka unbalanced movement. Isa ka unbalanced movement, which is FEM, o isa ka balancing joint is one cycle. Then another cycle is carryover moment. Then another balancing the joint, another balancing of joint. Okay, so how will you balance the joint? Again, you add negative of the sum of the moments, 1.06 plus negative 4.17 or minus 4.17 multiplied by 0.38. Okay, negative 1.06 minus 4.17 multiplied by distribution factor 0.38, pila? We have a positive 1.18. And then next is negative of the sum of 1.06 and negative 4.17 multiplied by distribution factor 0.62. So we have value of positive 1.93. Okay, so kanina po siya is second cycle. We cannot proceed anymore. Pa-proceed pa ba ta? Hindi naman ka maka-half. Kay zero naman ang imuhang dire. Wala na kay balance joint for A. So pag mo siyang i-sum up, no? Final moment so negative 2.11 plus 2.11, that is 0. Adding up 3.52 plus 1.83 plus 1.06 plus 1.18 for B towards A, we have positive 7.59. Then negative 8.33 plus 2.98 minus 4.17 plus 1.93, we have a negative 7.59. Then positive 8.33 minus 8.33, we have 0. Okay, so na kay value for moment at B. So internal moments are usually negative moments. So mag-prevail ang pagka-negative ni point B since internal siya. So Therefore, moment at A is equal to 0. Moment at B is negative 7.59 kilonewton meter. Moment at C is equal to 0. Okay?